Lab number 7. Write Yacc program to accept a statement and do the following error detection. The question or the objective is check for valid declarative statement and intimate the error to users. So here also you will be having a Yacc file and Lex file. Yacc contains the definition section which has the header file and the flag value, that is the variable defined. The tokens you are going to use here are, there are 5 tokens: ID, key, colon, comma, num. So these are the tokens which you are going to pass from your Lex to Yacc. So your rule section contains, again it is an augmented grammar, statement, derives, list. List is L. So your declarative statement grammar you may be remembering, D derives TL, L derives L comma ID or ID. Similarly only we are going to use here. It is S derives L. L is nothing but list here. This is the grammar. If it is successfully reducing towards your augment, that is the start symbol statement, print that declaration is validated. So your first start symbol has only one grammar definition, it ends with semicolon. Next, the definition of list. List can be key followed by list. So what is key here? Key is nothing but, you can see that key is a token. Key is your declarative statement, that is int, float, all those things are considered as the key here. Means D derives TL. T is the type. That is what specified as a key. That is declarative statement has to be int A or int A of 10, something like that. So it can be key followed by the list of identifiers. List can be list comma list also. Both are valid. If you have int A is also valid. If it have int A comma A is also valid. But if you have A followed by more than one comma, it should be syntax error. Consecutive commas used, it is invalid. That is the error message you are going to report to the user. Next, list followed by a colon, that is int A semicolon is also valid. Then if you have an array declaration, ID, that is an identifier. ID is nothing but an identifier, we'll see in the Lex file, followed by your num value within the subscript is also valid. If you have a grammar definition ID within bracket num followed by a dot, means that it is not valid, because inside the array subscript you have to use a integer value. So you have to consider, if there is a float or a identifier inside the subscript, you have to print appropriate error message that if it is dot, float point cannot be in the size of the array. If there is a identifier inside the subscript and identifier within the subscript, print that size of the array should be integer. So print appropriate error messages. Next, if there is an opening subscript, there is no closing subscript. Opening subscript, that is int A open bracket B, there is no close subscript, means a close bracket missing, you have to print the error. ID open bracket is there, size of the array should be specified, you have to keep, or it can be ID. Next, you have to specify what is colon. So you have used somewhere COL. COL is nothing but semicolon. So if there are more than one semicolon, you have to print the error message. If there is only one semicolon, there is no, that is valid. If there is more than one semicolon, print that syntax error, consecutive semicolon are used, invalid. This is your user subroutine section. YY parse is called. Valid declaration you have to enter, then YY parse is called. It will parse the input. If there is an error, it will print that invalid statement. Otherwise, it will print valid statement. So now we will see the Lex supportive file where the token declarations are done. So you have used 5 tokens there: key, then colon, then ID, then num, all those things. We'll see here which are the token declarations used. So in the user subroutine, in the definition section, you have y.tab.h, stdio.h and int yylval. Your rule section contains, that is the key. Key can be any of the, it can start with any of your basic declaration, basic data types: int, float, character, double, short or long int, followed by a space is considered as a key. So you can see in your Yacc, list means that key. key means it is starting with int or character or double or float or whatever with a space followed by the variable listing. So that is what whenever you have something like that in your input, it will return a token called as key. If there is any identifier, it will return as ID. If there is a number, it will return as number. All spaces will be neglected. If you have a semicolon in your input, it will return as colon. If the slash and 0, all other inputs other than the previous described pattern, all will be directly returned to your output. And in Vivera, you are going to return 1. So this is the Lex program. So it will just check whether it is a key or an ID or a number or colon. And there is a comma specified there. If you want, you can add here in the Lex pattern comma return comma. It is directly used in the Yacc as a character, so no need that you have to pass as a token. If you want to pass as a token, you can give here comma and return comma. Otherwise, directly use in the Yacc as a character. So here you can see that in the list comma directly is used. That is why you are not going to return this particular character as a token. So now we will see the revisit the grammar. List derives key list means that it has to be something like int a. It can be int a semicolon if you are following list colon, or it can be int a comma a. That is also valid because semicolon is the end of the input. You will be checking. So if you want everywhere that semicolon has to be checked, you have to change your grammar structure accordingly. So grammar has to be defined. Grammar will only check whether successfully it will reduce towards your start symbol. In the start symbol, it will print the final message that the declaration is validated properly. So this is how you are going to check the validity of your declaration statement. You are not going to add anything to the symbol table. If it is asked to enter the details of the valid declaration to the symbol table, you can take the symbol table entry and appropriately enter the messages there in the symbol table as well.